Okay, toward the end of class on Friday, I gave everybody this practice assessment for the lab test that we're having Monday. There's going to be 3 stations. It's not too bad. I'm pretty confident that you guys will all do pretty well on it. People usually do pretty well in the lab, this first lab assessment. There's going to be 1 station. On here, I had it broken down as 2 because there was going to be 2 different practices, but every single person will have a different sample that I've put at your tables. So there'll be like 24 different samples at all the different tables, and your job is going to be to take observations, and then based on those observations that you collect, you're going to make a claim about whether you think it's a metal, non-metal, or metalloid, and then back it up with that evidence that were your observations. So this isn't a test of, like, let's say I put like a little thing of like aluminum foil at your station. It's not a test of like, do you recognize this as being aluminum foil and therefore you should cater your answer toward being a metal. You want to act as if this were a new element that were discovered, and your job is to look at the 5 characteristics that we can observe in a high school classroom to try to give your opinion on whether you think it's a metal, non-metal, or metalloid. So we're going to focus on these 5 characteristics, and that's what I'm looking for points in this very first question here. You record your observations of the substance at your station 1. So we talked about 5 characteristics that we can quickly see in a high school classroom and observe and note on. So there's going to be 1 point that you actually talked about each one of those characteristics, and then there's another point for each one if you actually got the correct observation for the sample that I actually gave you specifically. So the first thing you're going to want to talk about for that sample is the state of matter, right? So is it solid, liquid, or gas? With a little description, right? So you might say it's a solid white powder, or it's, a silvery liquid, or it's a clear gas, or whatever it is. Make sure that you're commenting on that first. The next thing you want to look at, and again, these don't really have to be in order necessarily, right? But you want to look at and talk about, was the substance malleable, brittle, or were you unable to determine? So going back to what malleable means, right, technically it just means that your shape can deform under pressure. So a way that you can usually test it in a classroom is by picking it up to see if it bends, or if like you put enough pressure, can you kind of smash it down a little bit, right? Brittle means like, you apply pressure and the shape cannot deform at all. It'll break before it'll change shape. And there's going to be some substances where you're unable to determine. So if you remember back to that activity we did like a month or so ago when we walked around the room and looked at all the 10 different element samples, there were some samples that you picked up and you tried to bend it or break it, but you weren't strong enough to, right? So for all you knew, that substance was malleable and you just weren't strong enough to bend it, or for all you know, it was brittle, but you weren't strong enough to break it, right? So in a situation like that, you would have to say that you were unable to determine. And you don't just say unable to determine and nothing else. You would actually comment on, I was unable to determine if the sample was malleable or brittle because, with the force I was using, I was unable to break it or bend it, kind of thing. We talked about this on Friday a little bit too, and before when we did this activity, but if you have a powder that you have for your station, you technically would have to put that you were unable to determine, right? Anything can be ground up into a powder. I can take the most malleable metal, right, or the most brittle non-metal, and grind them up into powder. So just because it's a powder doesn't mean it was brittle. So that would be a situation too when you would have to say that you were unable to determine. And then kind of going along with malleability is the ductility of the substance. And if you remember, that means that you can be drawn into a wire. So we have to be careful with those observations, because just because something's malleable doesn't mean it's necessarily ductile, right? Like, you have to be malleable to be ductile, right? Your shape should be able to deform or change under pressure if we expect you to be drawn and strung out into a wire. But just because you're malleable doesn't mean you're ductile. And the example I always tell you guys in class that relates to this is like a soft chocolate chip cookie is malleable, but you can't take it and like string it out like you can chewing gum, right? So you can be malleable and not necessarily ductile. So since that's not something you can observe technically, like you shouldn't be putting it's ductile just because it's malleable, right? Because correct science would be, we're not just going to assume that it has that property, right? If you are unable to test it and actually see it for yourself, you would actually have to say that you were unable to determine. The only person that could say that their sample was ductile is if I literally give you a wire for your particular sample, right? If you can see that it's in wire form, then you have proof that there's ductility to that substance, and then you could report out, well, I know it's ductile, or I can observe it's ductile because it's already in a wire form. You can say something's non-ductile if it's brittle, right? Because if you're brittle, there's no way you could ever be drawn into a wire. So if you've already established that the sample was brittle, then you can say for this one, the substance would therefore be non-ductile, because if the sample already shows to be brittle, right, then obviously it would have to be non-ductile. And if you have a sample that, like, again, like it's malleable, but you can't draw it into a wire or anything, like, then you're saying that you're unable to determine that ductility. So you're either saying it's ductile if it's literally a wire, you can say it's non-ductile if you've already confirmed it's brittle, but any other situation, you would have to say that you were unable to determine the ductility. And then this should go without saying, but if your malleability you were unable to determine, your ductility you were unable to determine as well. Do you want this? What, babe?
What are you talking?
I'm making a video. You guys gotta be quiet.
Mommy, what are you talking? What are you talking?
So, sorry. So, there's 5 points for at least talking about each of those descriptions, or each of those characteristics, excuse me, and 1 additional point for if you actually got the correct observation for the sample that I gave you. Everybody in the class, again, has a different sample. And then after that, you go through, Anton, be quiet, please. And you have to make a comment, or not comment, you have to pretty much make a conclusion about, hey, is this a metal, non-metal, or metalloid? And then you have to justify it with your observations. So, we talked about, again, many times in class, that you cannot say something's a metal unless you are actually going to be able to confirm all 5 of those metal characteristics, right? You can't say for sure it's a non-metal unless you either can confirm all 5 characteristics, or unless you can confirm 1 characteristic that is unique to only non-metals. For example, if the sample you had was a gas, right, only non-metals can be gas at room temperature, so then you would know that that was obviously a non-metal. But usually we need to be checking off all 5 characteristics before we can make a comment on, yes, this is for sure a metal, or yes, this is for sure a non-metal.